All right, you guys, I'm just going to work through the Unit 4 review as quickly as I possibly can. Again, feel free to fast forward, rewind, pause. It's always a great idea to pause on every problem and then work it yourself and then unpause it and hear me go through it and see if you did it correctly. That's a great way to study and make sure that you're working it out correctly. All right, so here we go. The first one, what is the slope of all horizontal lines? I'm just going to draw a quick little graph of a horizontal line, right? Remember, horizontal lines go left to right, right? And so they have no rise and they're all run, right? So their slope is always 0, right? And then, of course, the slope of all vertical lines. Remember, vertical lines are the weirdos because they are not functions, right? They are all rise and no run, which means you're dividing by 0, but division by 0 is undefined, right? You cannot divide by 0 in math, okay? Then we get to graphing of the vertical and horizontal lines. So the first one says x equals 2. So remember, x equals 2, right? It's telling you that it's only crossing the x-axis at 2, right? So that means this would be our line right here. And then it wants you to identify the slope, which is, of course, undefined, which we just talked about. And then this one is y equals -4. So it doesn't have an x, which means he'll never cross the x-axis. He's only allowed to cross the y-axis at -4, right? So he's going to look like this. And, of course, that means he has 0 slope. All right, coming up here, write the equation of the line that goes to the 2 points. Now, I know most of you guys, your first instinct on your last quiz was to do the slope formula, which I'm totally fine with that being your first instinct because it technically should be your first instinct whenever you see 2 points is to find the slope first, right? So if you want to do it that way, you can. I am gonna do it that way really quick. So if I do y2 minus y1, that's gonna give me -8 minus -8. So it's gonna create a double negative. And then on the bottom, I'm gonna have -5 minus 11. So I'm gonna end up getting 0 over -16, which is 0. Now, please don't write 0 in this blank which some of y'all did that on your first quiz in this unit. It's not asking you for the slope, it's asking you for the equation of the line, right? So at this point, you need to be like, oh, I got a slope of 0. That's really weird. Oh, I got a slope of 0 because it's a horizontal line, right? And remember, horizontal lines, let me go back over here. Horizontal lines are of the form y equals some number. So I automatically know my equation is just y equals some number because it only crosses the y-axis, but it only crosses it where? That's when you want to go back up to your 2 points and you're like, oh yeah, I didn't notice that both of my y values were -8. Right? And if you notice that both of your y values are -8, then you could have hopped right to the equation. You don't even have to do any of this work, right? You can just literally notice that both of your y values are -8. Therefore, it has to be y equals -8. You could also, just to give you another little heads up, you could also sketch the graph, right? You could plot the points and be like, okay, let's see, 11, -8. Let's say that's right here. And -5, -8. So if you wanted to sketch yourself a little graph, then you'd be like, oh, it's a horizontal line. And it's a horizontal line that's crossing the y-axis at -8. Right? So there's so many different ways that you can get this correct answer, right? But over half of us missed that on the quiz, right? Because we just stopped, when we found slope, we just kind of stopped there and we didn't do anything with it, okay? All right, the next one, again, I'm going to kind of solve it the same way because most of you guys, your first instinct is to find slope. So I'm going to do that really quick. So that would give me 9 minus 0 over 2 minus 2, which gives me 9 divided by 0, which is undefined, right? Again, if you don't remember that, you can type that in your calculator. It's going to say error. And so as soon as I see an undefined slope, I'm like, oh, that means it's a vertical line. Now, do you even have to do any of that? Absolutely not. If you notice from the get-go, right, that both of your x values are 2, then that is giving you the equation. Oh, it's a vertical line. That means it only crosses the x-axis at 2. And then you're like, oh, that's why they have the same x coordinate. Again, you could sketch yourself a little graph if you wanted to. It never hurts to draw yourself a little graph. If I was to plot 2, 0, right, that would be this line right here, or this point right here, and then 2, 9 would be above it somewhere up here. So yeah, of course, this is my vertical line, right, going through x equals 2, right? All right, so we don't want to miss those, right? You don't have to find the slopes. I'm just doing that because most of you guys did that at first, and then you just kind of stopped there, right? But you have to realize, oh, it's a vertical or horizontal line. All right, number 5, how do you know if two lines are parallel? They have the same slope. Right, and of course they have the same slope because the only way two lines can never cross is if they are increasing or decreasing at the exact same rate. All right, so I'm just drawing a little example over here. So let's say this guy has a slope of 2/3. Then I know this line must also have a slope of 2/3 if they're going to run parallel to each other and never cross. Okay, number 6, how do we know if lines are perpendicular? They have opposite reciprocal slopes. All right, opposite, again, meaning plus minus, right? Anytime you see the word opposite in math, it means you're talking about the signs, positive or negative, right? And then reciprocal means to flip the fraction. And you must do both. It can't be one or the other. It has to be both. So let me just draw a quick little demonstration, right? So if I have an increasing line, let's say he has a slope of 2/3, and I have a line somewhere that is intersecting with him perpendicularly, which means it has to form a right angle. There'd be a right angle box there if I was being very specific. And I know his slope would have to be -3/2, right? The opposite reciprocal, right? And that's on you to figure out what that new slope would be. All right, now we can go kind of practice, which we did a bunch of these throughout the unit. So determine if the following lines are parallel, perpendicular, or neither. Please don't just write yes or no. This is not a yes/no question. All right, so you're determining parallel, perpendicular, or neither. All right, so obviously we need to find their slopes. All right, so I'm just going to write that. Find slope. If it's in y equals mx plus b form, awesome. All right, then you're good to go. This one is in y equals mx plus b form, right? So he clearly has a slope of 2. This guy's also in y equals mx plus b form, and he has a slope of -2. All right, are these the exact same slope? No. Are they opposite reciprocals? No, they're just opposites. They're not reciprocals. So this is neither. These are just intersecting lines, but they don't intersect at a right angle, right? So just random intersecting lines. All right, letter B, x equals 12. Okay, well, I need to remember that anything that says x equals number, right? That means it only crosses the x-axis, right? So right away, I know this is a vertical line, which has an undefined slope. And x equals -1/12. He's also a vertical line. He's just crossing at -1/12. Now, they're trying to be tricky here, right? Because these are technically opposite reciprocals of one another, but those aren't slopes because vertical lines don't have slopes, right? So this is a vertical line with another vertical line. So these are parallel. Don't fall for the trickery. Right? You're literally just graphing. Here, let me just show you really quick, right? If I was to graph these by hand, right, x equals 1/12 would just, be very close to that y-axis, right? This would be x equals 1/12, and then x equals 12 would be way out here, right? It's just two vertical lines on the same graph, so they would be parallel. All right, let's tackle this guy. I like the second equation a lot because clearly his slope is 5/2 because he's in y equals mx plus b form. But unfortunately, this guy is not in y equals mx plus b form. So we need to convert him. And we've done this probably over 100 times at this point, right? So we need to move the x term over to the other side by subtracting it over. So he's going to become negative. And I'm going to kick my positive 6 out to the side there. And then we need to divide everybody by -2. -2, -2, -2. And those cancel, of course. That's the whole reason we do that. So we end up getting y equals. Now you have to clean up all the mess that you've created over here by dividing by -2. So right here, we have a negative divided by negative, which is a positive. And of course, 5/2 is not reducible. So we're just going to leave that as positive 5/2 and then -3. All right, and so that's our first task, is to get it in y equals mx plus b form. And then I go find my slope, which is 5/2. And I compare that to my slope over here, which was also 5/2. So it looks like they have the exact same slope. So these would be parallel. Okay. All right, letter E. I've got a y equals number equation, right? So y equals a number. I automatically know this is a horizontal line. And then I have another y equals, so this is another horizontal line. They both have a slope of 0, right? That's interesting, which means these are parallel. Okay. All right, let's hop to E. X equals 3. Okay, that crosses the x-axis at 3. So this is a vertical line with an undefined slope. And y equals 3 is a horizontal line with a 0 slope. So please remember, and again, you don't have to sketch the graphs, but it's never a bad idea, right? If you need a little visual to help you out, right? When I graph these, x equals 3, right, would look like this. And y equals 3 would look like this. Right? And of course, every vertical is automatically perpendicular with a horizontal line. Right? So perpendicular. All right, letter F. What do we got? 2 more of these. Letter F, this is not in y equals mx plus b form. It's really close, right? We need to get this y by itself, which means we need to pick up this 9x and move it to the other side. So that's going to give us y equals -9x, and then kick that -11 out. And yay, that's in y equals mx plus b form, so our slope is -9. This one's already in y equals mx plus b form, so I can go ahead and identify my slope as -9. And it looks like those are the exact same slope, -9 and -9, so that makes these 2 lines parallel. All right, and lastly, it looks like both of these are in standard form, so we're going to have to do a little bit of work, right? So I'm going to take remember, it's the same 2 steps every time, right? So you pick up the x, you move it to the other side. Let's see, that's going to give me, sorry about that, 2y equals -x plus 7. And then, of course, we're not done because the y isn't by itself yet. So we're going to divide everybody by 2. And that's going to give us, I'll go ahead and cross these out. That's going to give us y equals, remember there's an understood 1 right there. So this is -1/2 x plus 7/2 or 3.5 if you want to. Again, I don't really care about the 3.5. I'm not graphing the line. I'm just trying to identify the slope of the line, which is -1/2. And on the other side, same thing. I need to bring my x term, right? Oops. I need to take our x term and we need to take it to the other side. So that is going to give us y equals positive 2x minus 3. And that's all we had to do because there's no multiplier in front of the y. So our slope is positive 2. So now we need to compare positive 2 with negative 2 or negative 1/2. Those are opposite reciprocals, so these lines are perpendicular. All right, moving along, number 10. Oh, actually, that's the next page. Let's go in order. Here we go, sorry. Number 8, write the equation of the line that goes through the point 6, 4, and negative 4, and is parallel to y equals 1/3 x plus 1. All right, so remember what I did in class, and you don't have to do this, but I would suggest it. Right, remember, we're writing an equation of an entirely new line, right? It has nothing to do with that line, right? Or it's not that line, but we're just using that for information. So we want to be parallel to this line. Well, this guy, he's already in y equals mx plus b form, yay. He has a slope of 1/3. Well, if I want to be parallel to him, that means my line needs to have the same slope. So I also want to have a slope of 1/3. But I also want to be passing through the point 6, negative 4. So I'm going to put that over here as well. So this is everything I know about my new line. He has to have a slope of 1/3 and pass through 6, negative 4. Now, unfortunately, this point is not a y-intercept, so I'm going to have to use point slope form, which it asked me to do that right here anyway. All right, so formula chart's handy, right? Please remember point slope form is y minus y1 equals m times x minus x1. So you have all that information right here. You literally just have to put it in the formula correctly. So y minus negative 4, right? Because it's a minus sign from the formula and the negative on the 4, so it's a double negative, so this just turns into a giant plus sign, equals 1/3 x minus 6. And we're done, right? Now we're going to take that point slope form, right? He acts as a middleman. He's going to get us into slope intercept form, so we have to convert. So I'm going to just show my steps, my math right here. Y plus 4 equals, we got to distribute the 1/3, so 1/3 x minus, and 1/3 of 6 is 2. And then, of course, we need to subtract the 4 over to the other side, which is going to give us y equals 1/3 x minus 6. Please make sure you are showing your work. 99% of mistakes are getting made because we're trying to do stuff in our head and we're not writing it down for ourselves to actually see all the signs and what's going on, and we're making silly mistakes. It takes literally, it takes 5 seconds, right, to convert or to add a constant to the other side and write it down on your paper instead of just doing it in your head, right? It's going to save us a lot of mistakes, right? So please make sure that you're showing that work, right? So you're not making silly errors. All right, now we have to go from slope intercept form to standard form, okay? Here, let me write down our forms for us. Here we go. All right, so now I'm going to go into standard form, which is ax plus by equals c. So I need all my x's and y's to the left. All right, well, that means I'm going to, you know what, I'm going to copy and paste this really quick. There we go. I'm going to start fresh with it right here. Okay. Make it a little smaller. Okay, so we need to pick up our positive 1/3 x. Oops. And we need to move him over here. So he's going to become a negative 1/3 x plus y equals negative 6. Please don't forget that that negative is on the 6 and bring him down. And then unfortunately, right, we're getting close, but we can't start with a negative and we can't have a fraction. So we need to get rid of the negative and the divide by 3 all at the same time. So we're going to multiply everybody by negative 3. And of course, this negative 3 cancels out with that negative 3. That's the whole point. So we're just left with 1x, and then we need to multiply everybody else by negative 3. So it's going to give us negative 3y equals 18. All right, and please don't forget, we talked about a nice, easy way to check our work, right? I'm gonna go over here, I'm gonna check my answer. Now, it's not foolproof, we talked about this in class, but I am gonna check after all that math, does the point that they gave me, does the point 6, -4 lie on my final standard form answer? So remember, I can just plug a 6 in for X and a -4 in for Y and see if I get an equal statement. So I'm going to do that really quick. So 6 minus 3 times -4, does that, I'm going to put a question mark, equal 18? Well, if I type this in my calculator, that's 6 plus 12, because the double negative, which does give me 18. Is 18 equal to 18? Yes, indeed, and I'm gonna put a little smiley face. Now again, that doesn't 100% guarantee that my answer is correct, but it does prove that the point they gave me does lie on my final answer, right? Which is a pretty good indicator that you're probably correct, okay? All right, number 9 is exactly the same, except it says perpendicular to the given line. And it's very friendly, right? They gave it to us in y equals mx plus b form, so that was super nice, right? So I am going to go off of the side over here, and I'm going to write down the information for the new line. So I need the opposite reciprocal of -3/4, which would be +4/3. And I want to pass through the point -2, 3. So this is our information here. All right, and now we should be good to go, right? Now we just hop to point slope form. Y minus 3 equals our slope of 4/3 times x minus -2. So that double negative would change to a positive. And that's it. Point slope form doesn't require any actual work. You just have to plug everything into the appropriate formula. All right, I'm going to paste that down here so I can mess around with that equation, because now we need to get it in slope-intercept form, which is 2 steps, right? We need to distribute. So we're going to get y minus 3 equals 4/3 x. Now, please use your calculator if you don't know what 4/3 times 2 is, right? That's going to give us 8/3, right? Use your calculator, right? All right, and then our last step would be to add the 3 to the other side. Again, use your calculator, right? That's going to give us y equals 4/3 x. Remember, our slope can't change from one form to the next here. And that's going to give us, use your calculator to do this math. Please do not assume you know how to do that if you don't, right? 8/3 plus 3 is 17/3. And please use the fraction mode on your calculator, right? Do not write 5.6 repeating, right? Don't round. We don't use rounded or repeating decimals in high school, right? So just leave it as 17/3. It's okay. All right, now we're going to take that slope-intercept form. I copy it so I can mess around with it. Here we go. All right, now we want to get that in standard form. Okay, so same steps, right? We're going to take our 4/3 x, right? And we're going to bring him over here because the x's need to be on the same side as the y's in standard form, but that's going to make him negative. And you might be thinking, oh my gosh, I have 2 fractions, right? I got 2 fractions to get rid of, but luckily they have the exact same denominator, right? So I'm gonna multiply everybody by 3, but I'm also gonna have to multiply everybody by negative, right? To get rid of that negative starter. So just like the last problem, we're gonna multiply everybody by -3. And let your calculator help you with this, right? If you need help. So this -3 cancels out that -3. Or you can literally use your calculator and just type in -3 times -4/3, and it's going to tell you that it's 4. So 4x minus the 3y, and then again, use your calculator. If you don't know what 17/3 times -3 is, type it in your calculator, and it's going to tell you that it's -17. And that should be our proper standard form. Now, you know what I'm going to do next? I'm going to go check that answer because that was a lot of algebra, lots of fractions, right? And I want to make sure I didn't mess any of that up anywhere along the way. Let's see, what was our point? -2, 3. So I'm going to take the point -2, 3. I'm going to plug the -2 in for the x and the 3 in for the y. Okay, so here we go. 4 times -2 minus 3 times 3. And then question mark, does that equal -17? Well, I don't know. Let's go do the math. -8 minus 9. Yeah, it does. Right? That gives me -17. Right? And so I'm pretty sure I didn't make a silly mistake along the way, and I should be good to go. All right. Let's go look at number 10, next page. We're halfway done. Determine if the lines below are parallel, perpendicular, and either justify your answer. Please do not just look at the graph and say, yes, it's perpendicular, right? They're clearly not parallel. You must prove it, right? That's what justify means. And in this case, we have to prove if we're going to say these are, because does it look like a right angle? Yes, but maybe it's not a perfect right angle. What if it's like an 89-degree angle? Like we wouldn't be able to see that. So you have to prove it. So that means finding your slope. So I'm going to do my decreasing line first. So let's see. I'm going to go down, down, down. Okay. So he has a slope of -2 or -2/1 if you want to write it as a fraction. Then I'm going to go find the slope of my other line. Looks like it's going through this point and this point and this point and this point. And that is a slope of +1/2. All right. Are those opposite reciprocals? They sure are, right? So these are perpendicular. And as far as justifying, this is your justification, right? That's really all I want to see. If you want to write, because the slopes are opposite reciprocals, right, then you can. But I want to see those opposite reciprocals, right? So just make sure you're showing me your math. All right, number 11, determine if they're parallel, perpendicular, or neither. Okay, well, they clearly don't. They look kind of parallelish, but I'm going to prove it. So let's see. I'm going to go find some slope. Looks like up 1 over 1, up 1 over 1, up 1 over 1. So it looks like he has a slope of 1 or 1 over 1. And then up 1 over 1. Oh, it looks like this guy's doing the same thing, which means he has the exact same slope. All right, so these are definitely parallel. Okay. Okay. Number 12, determine if the lines below are parallel, perpendicular, or neither. Okay, you can probably guess where this is going. Let's see. It looks like here's a point, and I don't hit another point until right here that I can identify. So that looks like we're going up 1 over 4. So he has a slope of 1/4. And then let's see on this other guy, here's a point. Oh, it looks like that's another point right there. So it looks like we're going down 3 over 1, -3 over 1. Right? Are those the same slope? No. Are they opposite reciprocals? No. Right? Kind of close, but no. Right? The opposite reciprocal of 1/4 would be -4, right? So this is neither. They are intersecting, but that is not a perfect 90-degree angle, and I know that because they don't have opposite reciprocal slopes. Okay. All right, let's hop back up to this column. Write the equation of the line that is parallel to the x-axis and goes through 5, 2. Now, you don't have to draw the graph, but you should. Right? There's literally a graph right here to help you identify what that equation is, right? And so let's go do that. Let's see. It has to go through 5, 2. So I'm going to plot this first. So 1, 2, 3, 4, 5, 2. If you don't plot your points correctly, then your answers are going to be incorrect. So be very careful. And then it says parallel to the x-axis. Okay, well, here's the x-axis. So if I'm running parallel to that, I know that has to be a horizontal line. But it also has to pass through that point that they gave me. So I'm looking for the equation of this line right here. Well, he's a horizontal line, and he's only going to cross the y-axis at 2 for his entire life, and that is his equation. Okay, please use the graph, right? These don't require any work whatsoever, right? You could also just be like, oh, I know he's horizontal, so therefore y equals 2, and you can just use the point, okay? But if you're given a graph, always use it to your advantage, okay? All right, number 14, write the equation of the line that is perpendicular to the y-axis. Okay, we'll come back to that in a second. And passes through the point 3, -4. Okay, I'm going to plot the point first, right? So 3, -4, 1, 2, 3, 4, right? Write 3 down, 4 is what that's telling me. All right, now let's talk about that perpendicular to the y-axis, right? Here's the y-axis, and we want to be perpendicular. So we want to cross the y-axis at a right angle. So we're talking about this line right here, right? So we want the equation of this line. Well, he's also horizontal, but he's crossing at -4. So his equation is just y equals -4. Okay. All right. And yet another one. Here we go. Write the equation of the line parallel to the y-axis. Again, we'll get to that in a second, but passes through the point 5, 2. I'm going to plot that first. Over 5 up 2. There's the point 5, 2. And I want to be parallel to the y-axis. Well, here's the y-axis. So if I want to run parallel to that axis, then that means my line is going to be a vertical line. So I want to write the equation of the vertical line, right? And he's only crossing the x-axis at 5. So his equation is x equals 5. Again, no work necessary, right? We don't want to miss these questions on the test, right? You want to use the graph so you can see exactly which axis that's crossing. All right, last one. Write the equation that's perpendicular to the x-axis. Again, we'll come back to that in a second. That has to pass through 3, -4. 1, 2, 3, 4. I'm going to go ahead and plot that. And we want to be perpendicular to the x-axis. Well, here's the x-axis. And perpendicular to him means I'm crossing the x-axis at a right angle. So that would mean here. All right, so if I'm perpendicular to the x-axis, that means I have to be a vertical line. And my vertical line is only crossing the x-axis at 3. So that is our equation. Okay. All right, enough of those. Let's go look at transformations. All right, okay. So with our transformation problems, right, these are where you just have to know your rules, right? So this one is giving us the original function, right, 2x minus 1. Again, we don't care though. We don't care what the original function is. We just care about this function notation form, this transformation form, and we can totally tell that the way this is written, right, here's my, oopsies, sorry, keep messing up my highlighters. Right, here's f of x, and here's the f of x that they're talking about right there. Right, so all of that is being inserted right there in that f of x, right? So we don't have to worry about it. It's all there. What we have to worry about is what does the 2 multiplier, right? What does this, and this do to that original graph? Okay, so I'm just going to kind of take these one at a time. I'm going to erase these arrows until I need them. Sorry, let me do a better job of highlighting just that. There we go. All right, so this positive 2 multiplier in the front, he's outside the parentheses, so I know he's a vertical something or other, and that means that we're making the function 2 times taller. So this is a vertical stretch by a factor of 2. Okay, he's making our line steeper, right, because we're vertically stretching him out. Then we have the plus 1, but he's inside the parentheses. And remember, anything trapped inside the parentheses with that x is automatically a horizontal change. So you're either shifting horizontally or stretching or compressing horizontally, right? So anything inside is a horizontal move. And anything trapped inside with the X is always the opposite of what you would think is actually happening. So when I see a +1, I think, oh, shift right 1, but it's not, it's shift left. So we're shifting left 1 unit. Please make sure on your test that you don't just say shift left. Make sure you actually put the 1. And then our last one is the -3. He's definitely a vertical movement because he's outside the parentheses. And what you see is what you get on the outside. So that would mean vertically I'm going down 3. So shift down 3 units. All right, moving on to this next one. Again, they're giving me the original f of x, but I don't care about the original f of x. I only care about what's happening to it, right? So we just need to describe what all these other numbers are doing on the outside. This is a -1 multiplier, and anytime you see a -1 multiplier, that is a reflection over, now this is on the outside, so he's negating the y's, which means he's a reflection over the x-axis. All right, then we have this 1/5, which I know is a horizontal change because he's inside with the x. And remember, it's always the opposite of what you think. So it kind of looks like a compression, but it's not. It is a horizontal stretch by the reciprocal of 1/5, which is 5. And we talked about this in class, right? Remember the demonstration of our walk to school, right? This means my function is going 1/5 his normal speed. So if I'm going 1/5 my normal speed, right? It's going to take me 5 times longer to complete my function, right? And so 5 times longer is going to be a horizontal stretch. Okay, and then lastly, we have this +8. He's on the outside, so he's affecting the y's or the vertical, and what you see is what you get. So this is a shift up of 8 units. All right, that's pretty much all you have to know from day 4, right? It's just your transformation rules. No work necessary there. All right, and then our very last topic was graphing inequalities. All right, so this was the most recent. So remember, this is no different than graphing any other line except inequalities have infinite solutions. So you have to shade, right? And you have to pay attention to the fact that it's not an equal sign. So you have to either do, these are the questions you have to ask yourself. I'm going to say dashed line or solid line. That's the first question. And then the second question is, do I shade above the line or below the line? Right? So these are the 2 questions that you have to ask yourself when you're doing inequalities. Other than that, it's exactly the same as any other linear equation. It needs to be in y = mx plus b. You're going to graph the b and then the slope and then graph your line, all that good stuff, and then ask yourself these questions. All over the place. Sorry. There we go. So it is in mx plus b form, which is awesome. So I'm going to go ahead and start with my y-intercept. Here, I'm just going to go ahead and make sure I'm going to write y. I'm going to put mx plus b, so we're good. So my y-intercept is 1, and then my slope is -2/1. So down 2, right 1. And please make sure it's a decreasing line, right? A negative slope has to have a decreasing line. So there's our line. Now, before I just go ahead and draw some solid line all the way through there, I now need to go focus all my attention on this guy, right? And he's what answers these questions over here. I kind of color code that a little bit. All right, so it says my y values are greater than the line. Well, the first thing that tells me is there's no equal to bar, right? So that means I can't actually equal any of these points that are on the line physically, right? So like this point, this point, this point, this point, none of those are solutions to this inequality, right? Because it doesn't have an equal to bar. So that's the first thing. So it's a dashed line because there's no equal to bar. And then the second thing is the shading. Well, this right here tells me that my y values are all greater than the line. Well, here's my current y value, and I want all the y values that are greater than that. So I want everything above the line. or I want the half that is containing these upper y values to infinity, right? And so this is the side I'm going to shade. And again, you can scribble it, you can draw some lines. I just have to be able to tell which side you're shading. And remember, the whole point of shading is because that's your solution region. Inequalities have infinite solutions, right? And so all your infinite solutions are every single point that lies in that shaded space, okay? All right, so down here it says, give me a point that's in the solution. Okay, let me pick a color. I'm just gonna pick some random point. I'll pick this one. He's in the shaded region, and that looks like the point 4, 2. Again, infinite answers, right? You don't have to have the same answer as me as long as it's somewhere over in that shaded solution region. And then I want a non-solution, which would be a point that is not in the solution region. Okay, I'm just gonna pick this point. Why not? He's definitely not in my solution region. What is that, -4, 0? All right, again, you can pick any point as long as it's over here somewhere and not in the shaded region. Okay. All right, let's see, I'm hopping up here to 20, or part B, I guess. That was part A. All right, so here we go. We're gonna graph this linear inequality, same exact steps. My only issue right away though is he is not in y equals mx plus b form, right? So step number 1, convert to y equals mx plus b form, which again, this is our 5th week practicing this skill, right? We do it over and over and over every single day, right? We should be awesome at it by now. Okay, so same 2 steps. You move the x. These steps never change, right? You move the x. Okay, what's that going to give us? -y. Please don't forget to bring the negative down, right? He belongs to the y. Is less than or equal to -x, right? Because the only way to move a positive x over is to subtract it, so he's going to be negative, -5. And you're not done because you have a -1 multiplier, so everybody needs to get divided by -1. And little bells should be going off because when you solve inequalities, whenever you divide by a negative, right, your inequality must flip, right? So he's going to become a greater than sign because we divided by a negative. If we didn't have to divide by a negative, then the sign would just stay the same as it was at the very beginning of the problem. All right, now we got to clean up our mess over here. A negative divided by a -1 would give us a positive 1x, or just x. And a -5 divided by a -1 would give us a positive 5. All right, so that is what we are graphing. Okay, here we go. Our y-intercept is 5, so we're going to go up to 5. 1, 2, 3, 4, 5. Oh, we're at the tippy top of our graph. And our slope is +1. So we should be going up 1 over 1. Now I know that's off our graph. So I'm going to go, instead of going up 1, right 1, I'm going to go down 1, left 1. Right? And I'm going to get all the points over here since I don't want to run off my graph like a crazy person. And there we go. I'm going to erase that. Now, once you have all your dots for your line, you have to ask yourself, is this a solid line? Yes, it should be a solid line because there's an equal to bar. So we can actually, equal every single one of these infinite points that lies on this line. Okay. And then we need to figure out if we're shading above or below. Well, this says y is everything greater than. So that means we should be shading above the line, which would be here. It's a very tiny little shading region. All right, same thing. We're going to find a solution point. What color did I use over here? I used purple. I'll do the same thing. I'll use blue. So I'm just going to pick any random point. I'll pick this guy. Why not? Any point in there. What is that? -4, 4. And then I need a non-solution, and I'm just going to pick the origin because why not? He's a super easy point to identify, right? He's definitely not in my solution region because he is not in that shaded region. All right, let's do another one. All right, this one is not in y equals mx plus b form, but it is in point slope form. So if you want to just leave it as is, totally fine with that, right? Our slope is clearly -1/2, And then remember, the point is -2 would be my x, and my y would be +4 if we plucked the x1, y1 out of the formula. So if you don't want to do the work to put it in y equals mx plus b form, you don't have to. Point slope form is just as awesome to graph, right? Because I can just graph the point -2, 4, and then apply my slope of -1/2, which would be down 1 over 2, down 1 over 2, down 1 over 2, etc. Now, if that makes you uncomfortable or you think you might mess that up, then go ahead and convert it to y equals mx plus b form. I'll just do that really quick in case anybody wanted to go that route. So you have to distribute the -1/2, which would give you -1/2 x minus 1. And then you would need to add the 4 over to the other side. And that would give us y is greater than or equal to -1/2 x plus 3. And notice that that's exactly where my y-intercept is, +3, right, with the same slope of -1/2. So whichever way you want to approach this problem, that is totally up to you, right, just kind of wherever your comfort zone is there. But once I have it graphed, I need to ask myself, is it a solid line or a dashed line? Well, this little equal to bar would tell me that we can actually equal those points that are on the line. So I'm going to go ahead and make that a solid line. Oh, that's not going the right way, is it? Oh, he's still a little crooked, but I'm going to let that go. And then we need to pay attention to the inequality symbol itself. It says greater than. Well, remember, right now, these are our y values, and I want all the ones greater than that, right? And all my greater y values are above my line. So when I shade, I want to be above the line. Okay. All right, a point in the solution set. You know what? I'm going to pick this guy. He's on my line. Therefore, he is a solution because it's a solid line. So he would be perfectly fine to go grab. So that's 4, 1. And you know what? I'm going to pick the origin again. He's not in my solution region, and he's a really quick, easy one to go grab. So 0, 0 would not be a solution. All right. We're going to do a couple more of those. All right, here we go. Luckily for us, this one is in mx plus b form. So he's ready to go, right? So -3 is our y-intercept. And then we've got a positive slope. So we should have an increasing line up to over 3. And I'm going to go ahead and go down to over 3. All right, now we need to go look at that inequality symbol, right? I do not see an equal to bar, which tells me that this should be a dashed line. That means none of the points would work that lie on the line. And it says, why is everybody less than the line? Okay, well, here's my current y value on the y-axis, and I want the side where all my y values are less than that. So less than means I'm shading below the line. All right, and again, we're going to pick a solution point. I'm just going to pick this guy, not for any particular reason, just because he's in the shaded region. What is that, 4, -2? All right, and to change things up just a scotch, a non-solution, I'm going to pick this point right here. He is not a solution because he's on the line, but the line is dashed, right? Now, you don't have to pick that point. I'm just making a point, right? No pun intended, that that none of the points that actually lie on the line itself are solutions because it's a dashed line, right? Obviously, you could have picked the origin again or any point up here in this non-shaded space. All right, number 20, determine if the following points are solutions or not. Okay, I noticed when some of y'all were taking the quiz, you were trying to graph these and like find the solution region and all that kind of stuff. Guys, don't do that. If a graph is not provided, then the intention is not for you to graph it, right? The intention is for you to plug in a 1 for the x, right? And a 9 in for the y, and see if it's a true statement or not, right? That is the intention for this problem. So here we go. I'm going to plug it in. 2 times 1 minus y, which is 9. Is that greater than, again, I'm putting a big question mark over that because that's the whole point. Is it greater than negative 7? Well, I don't know. Let's see. What do we get? 2 minus 9. Well, 2 minus 9 is negative 7. Is negative 7 greater than negative 7? No. It's equal, and there's no equal to bar. So no, 1, 9 is not a solution to this inequality. He would actually be the scenario that we just talked about, right? He would be on the line, but it would be a dashed line clearly, right? And so that's why he's a no. But again, just plug it in, right? It's 2 steps of work. It's so much quicker than actually graphing it. Not that you can't graph it, right? If you get stumped and you think you can draw an accurate enough graph, then by all means, right? All right, last one on B here, same exact thing. They want us to plug in a negative 2 for the x value, and then plug a negative 3 in for the y value, and see if we get a true statement or not. All right, so here we go. I'm going to rewrite this whole inequality, but instead of y, I'm going to substitute a negative 3. Is that less than or equal to, again, I'm going to put a big question mark over that, 4 times negative 2, because that's my x value, plus 6. Please notice I don't have any x's or y's left at this point because I've substituted numbers in for them, right? When you substitute a number in for a variable, the variable should not be there anymore. All right, now we just need to do that math on the other side. You can just type in your calculator, right? That's going to give me negative 8 plus 6, which is negative 2. And then I just look at this. And ask myself, is negative 3 less than or equal to negative 2? Yeah, it totally is, right? Remember on the number line, the negatives are reversed, right? So yes, negative 3 is less than negative 2, which means yes, the point negative 2, negative 3 would lie in the shaded region if I were to graph it, right? But again, it's so much faster not to have to graph it, but if you want to, you can. All right, and then we're up to our very last question here, or 2 questions. Write the inequality of the graphs below in all 3 forms. It just says the 2, but we're going to do 3. All right, so let's see, slope-intercept form. I got to go find my slope. So let's go find some points. There we go. So it looks like our slope is going down 1, right 3. And it looks like our b value, or our y-intercept, is 0. Okay, so I'm going to write y equals mx plus b, so negative 1/3 x. If you want to put plus 0 on the end, you're more than welcome to, but it's not necessary. All right, now we need to do point slope form. Well, I'm going to go pick a point. I'm not going to pick 0, 0 because that's the intercept. I'm going to go pick another point. I'm going to pick this guy over here. So I'm going to pick negative 3, 1 to do my point slope form with. You can pick any of the 3 points. I don't care which one you pick, right? Because everybody could get a different point slope form here, and they would all be correct as long as you plugged your numbers in correctly. So I'm going to use negative 3, 1, which means my point slope would be y minus 1 equals negative 1/3 x minus negative 3. So the double negative would make that plus 3. All right. And then, of course, I need standard form. Well, I'm going to use my slope-intercept form. I'm going to copy and paste that over here, right? All right. I'm going to do all of my work with this guy. Okay. So there. All right, so I'm going to pick up my negative 1/3 x and move him over here to join my y's, which is going to give me 1/3 x plus y. Now remember, there's 0 left over here. You do have to put that 0. You just can't have some vacant empty space on one side of your equation. All right, so we want to make sure we put a 0 there. And we are close, except we just cannot have a fraction in standard form. So we need to get rid of that divide by 3 by multiplying everybody by 3. And of course, this 3 multiplier and 3 divider cancel each other out. right? Which is going to give us x plus 3y equals, and of course 0 times 3 is still 0. And so that is our standard form of this equation. All right, let's go do it again. It's our very last one. Oh, I am so sorry. I just completely disregarded the fact that this was an inequality. Oh my goodness, rewind. I'm so sorry. Oh, goodness gracious. Okay, so here we go. I just totally disregarded the fact that this is an inequality and there's a shaded region, and I just put equal signs everywhere. Goodness gracious. Okay, so let me take all that back out. Oh my gosh, I lost my 0. Okay, I'm so sorry. Let's go back and fix that. I don't know why I did that. All right, so obviously we can't have equal signs because of the shading. So you need to figure out, is it a less than or a greater than? Okay, well, obviously this one is shading everything below the line, right? So if I'm shading below the line, that is a less than. And my line is solid, which means there is an equal to bar underneath there. Now, when I write things in point slope form, that of course is not going to change my symbol, right? It's still going to stay less than or equal to. Now, as far as our standard form, we do need to ask ourselves, at any point in the converting process, did we multiply or divide by a negative number? And no, we didn't, right? We multiplied by a positive 3, and that doesn't make any change in our inequality symbols, right? So this one would also just be remaining a less than or equal to the whole time. Okay. Oh my goodness. Sorry about that. Okay, so all less thans are equal tos. All right, let's go try B. I won't make that mistake again. Sorry about that. Here we go. I'm going to do my y equals mx plus b. So here's my y-intercept. And it looks like I'm hitting here and here and here. So that looks like a slope of positive 2 or 2 over 1. And then my y-intercept was negative 2. So I have my m and my b. So I'm just going to go ahead and throw that into y equals mx plus b form. So y 2x minus 2. But I'm not going to put an equal sign. I need to figure out whether this is a greater than or less than situation. Well, here's my current y value, that negative 2, and I'm shading the side that has everything greater than negative 2, so that tells me this is a greater than. And it's a dashed line, which means I am not going to have an equal to bar. Right, and so that is my final answer for my slope-intercept form. Scoochie him down. Okay, now point slope form, again, I'm just going to pick any random point on this graph. I'm just going to pick 2, 2. Right, so I'm going to use 2, 2 as my x1, y1 in my point slope form. Again, you can pick any of these points. It does not matter. Right, so my point slope would be y minus 2. I'm still going to be using greater than because the sign doesn't ever switch because there's no multiplying or dividing to go from slope-intercept to point slope or vice versa. So y minus 2 equals slope 2 times x minus the x1. That's a lot of 2's. 2's, 2's, and 2's. All right, and then last but not least is standard form, which I'm going to use my slope-intercept form. I'm going to copy and paste that over here. I'm going to use him to get into standard form. Again, it's the same 2 steps. So I'm going to take my positive 2x, and I'm going to move him to the other side, which they has to change signs because we're subtracting it over. There we go. Okay. And then we do have to get rid of this negative 1, technically, right? This negative multiplier in the front. Please do not move the 2. The 2 is fine. He's not a fraction, right? I want to keep the 2. The only thing I have to get rid of is the negative, right? So all I'm going to be doing is multiplying everybody by negative 1 or dividing everybody by negative 1. It's the same effect, so it doesn't matter, right? But I am multiplying by a negative, right? Which means our sign needs to flip. Let me scooch that down. All right? That inequality symbol has got to flip around because we multiplied by a -1. Or if you divided by -1, it doesn't matter. Either way, it changes the truth value, so we need to flip that around. So our final standard form is the 2x minus y is less than 2. And if you want to check yourself, right, you can always take this standard form and you can convert it back into y equals mx plus b form and see if you get that guy. All right. Okay, that finishes up our Unit 4 review. Feel free to rewind, go back and look at any of the problems that gave you trouble. There's extra practice in Canvas if you want some more problems to do. If you just need to practice converting between forms, just write yourself out some standard form problems and convert them, right? But you can always come in for tutorials before the test too, and we can talk about anything that you need help with. Okay? All right, happy studying.